resultant of coplanar forces. When a number of forces acting on a body, it is difficult to identify the direction of that body. If these forces are converted into single force, then we can easily find out the direction and the force with which the body is moving. From this, we can say that a resultant is a single force which can replace a set of forces in a force system and causes the same external effect. From the figure, we observe that the forces F1, F2 and F3 are acting at a point A. Then R represents the resultant of F1, F2 and F3. R is finally represented as the addition of F1, F2 and F3. Parallelogram law of forces. If two forces acting at a point are represented in both magnitude and direction by the two adjacent sides of a parallelogram, then the resultant of these two forces is represented in both magnitude and direction by the diagonal of parallelogram passing through the same point. P and Q are passing at an origin of O are represented as two adjacent sides of a parallelogram OA and OB. Then complete the parallelogram by drawing BC and AC. And the diagonal passing through the same origin point O is taken as resultant. Draw a perpendicular from C and extend OA up to D. From the figure, we can observe that OB is equal to AC is equal to Q and OA equal to BC equal to P. Consider triangle ACD. From that ACD, we can write cos alpha as AD by AC, means adjacent side by hypotenuse. We can replace AC with Q, then we can rewrite this equation as AD is equal to Q into cos alpha. Coming to the sin alpha is equal to opposite side by hypotenuse. Here, sin alpha is equal to CD by AC. Here also, we replace AC with Q, then we can rewrite this expression as CD is equal to Q into sin alpha. Consider a larger triangle OCD. From that triangle, by using Pythagoras theorem, OC square is equal to OD square plus DC square. We substitute OC as a R, OD as OA plus AD, DC as Q sin alpha. We can rewrite that equation as R square is equal to P plus Q cos alpha whole square plus Q sin alpha whole square. By equating this equation, we will get R square is equal to P square plus Q square cos square alpha plus 2PQ cos alpha plus Q square sin square alpha by using A plus B whole square formula. By solving this, we are taking Q square as a common from Q square cos square alpha and Q square sin square alpha. We will rewrite the expression as R square is equal to P square plus Q square of cos square alpha plus sin square alpha plus 2PQ cos alpha. Then we will substitute cos square alpha plus sin square alpha as 1. Then we will get an equation R square is equal to P square plus Q square plus 2PQ cos alpha. Then we will get magnitude of resultant R is equal to square root of P square plus Q square plus 2PQ cos alpha. Coming to the direction of resultant, consider the triangle OCD. Tan theta is equal to opposite side by adjacent side. Tan theta is equal to CD by OD. We will substitute CD as Q sin alpha and OD as P plus Q cos alpha. Then theta is equal to tan inverse of Q sin alpha by P plus Q cos alpha. This theta represents the angle or the direction of resultant.